Okay, we have done quite a bit with triangles over the course of the first semester, and we started to get into quadrilaterals a little bit. We haven't really done a whole lot with polygons in general. So we're going to start that now, and we're going to be doing formulas involving polygons. If you want to follow along, this is 7.3 in your books. Now, our objective for the lesson is to be able to use some important formulas that apply to polygons. And that's any type of polygon, be it a hexagon, heptagon, decagon, and I'll get into the different classifications of those in a second here. But these formulas apply to any of those, and you'll see how in a second. So just a quick reference guide. We have number of sides and polygon name. Now we're going to go through some that you know, such as, if it has 3 sides, it's a triangle. If it has 4 sides, it's a quadrilateral. And you might know some of these. 5 sides is a pentagon, 6 sides is a hexagon. From there, you might not know that 7 is a heptagon. That you probably know 8 is an octagon, 9 is a nonagon, 10 is a decagon, 12 is a dodecagon, and 15, and I'm probably going to butcher this, we're going to say that's a pentatagon. Okay, but what do we do if we say, oh wait, what if I have an 11-sided one? Where'd he go? Does he not have a name? He does. We call it an 11gon. If it's like a 14-sided, it's called a 14gon. If it's got 40 sides, 40gon. Kind of lame, but think about it. You really want someone to come up with a name for all these different shapes. So really, these are important to know. So I would focus on the ones that you don't know and find a way to remember those, because you're going to have some questions that say, find the number of interior angles of a dodecagon. And you're going to have to figure that out. Well, how many sides does a dodecagon have? Because they're not giving me a image to go off of. So just something to keep in mind. Learn these here. Okay? All right, so now how to find the sum of the measure of all angles of a given polygon. So let's say I've got this shape here, and it's got 1, 2, 3, 4, 5, 6 sides. So we've got a hexagon. How do I find the sum of the measure of all the angles? And when I say that, I mean all the interior angles. No, these are not all congruent. I'm just using that to illustrate that. Okay, so all of these angles. How do we figure it out? Well, if we have a hexagon, like we have shown below, and I'm going to get rid of these marks here, we can start at the vertex and draw all the diagonals from that vertex, all the ones that we can. However, many triangles you end up creating is going to help us determine the total number of degrees. So let's say I pick this vertex and I draw in my diagonals. I can only draw 3, because if I try to draw it to either of these 2 sides, it just forms a side, so it's not a diagonal. So that gives me 1, 2, 3, 4 triangles. So what we can do is 4 times 180, and that equals 720. So that means that there's 720 degrees in a hexagon. And this works for any particular type of shape. Now, if you don't want to draw it out and you want an easier way to do it, we have a theorem for that. It's Theorem 55, and it says the sum, which I'll refer to as S sub I for interior angles, of the measures of the angles of a polygon with n sides, and that's where the interchangeable part comes in. It doesn't matter how many sides it has, this formula will work. If you know it's a hexagon, we replace n with 6. If you know it's a pentagon, we replace n with 5, so on and so forth. And we have this formula. S sub I equals n minus 2 times 180. Okay, so let's say I had a quadrilateral. There are 1, 2, 3, 4 sides. So I could plug in 4 for n. 4 minus 2, which is 2, times 180, means that the inside angles add up to 360. Okay? And sometimes these vertex angles of a polygon may be referred to as the interior angles of the polygon. Okay, the inside ones, these vertex angles, that's inside the polygon. That's why we say sub I interior. Okay? And now, like with a triangle, we kind of touched on this before. If we were to extend out a side of a polygon out from any vertex, so like let's say I had this vertex here, and I extended this side out, okay, it creates a supplement to that side, to this line right here, okay, which leads us to Theorem 56. If one exterior angle is taken at each vertex, the sum of the measures of the exterior angles of a polygon is given by the formula S sub E. E is exterior equals 360. So it doesn't matter how many sides your polygon has, be it 3 if it's a triangle or 30. When you add up the supplements of all the vertexes, it is always going to equal 360 degrees. Okay? So, interesting little fact. So, like I said, there's sum of all the exterior, and the thing I want to point out, it's the sum of all the exterior angles is always going to be equal to 360. Okay? One last theorem to go. And that is 57. The number of D diagonals that can be drawn in a polygon of n number of sides is given by this formula. D equals n times n minus 3 all over 2. Okay, so yes, we can sit there and draw the diagonals and count them, but this is a much better way, and we're less likely to make an error using it. So like a triangle. Okay, can we draw diagonals in a triangle? We've got this figure here like this. Can I draw from this angle, can I draw a diagonal that'll go to either of these that aren't a side? Answer is no, and if you plugged it in, you'd be, okay, well 3 times 3 minus 3 over 2. 3 minus 3 is 0. 3 times 0 is 0. Divided by 2 is still 0. So there's 0 diagonal, so it works for that. Okay, we know in a rectangle there are 4 sides, and we know that we can draw 2 diagonals in that. So if we plugged it in here, 4 times 4 minus 3 divided by 2. 4 minus 3 is 1. 4 times 1 is 4. So that tells us how many diagonals we can draw. It will come in a little bit handy, so don't think that it won't. All right, let's move on to some examples. Okay, let's find the sum of the measure of the angles of a quadrilateral. Do you remember the formula for interior angles? Hopefully you do. Quadrilateral, side of the interior angles is the number of sides, so it's n minus 2 times 180, remember? So 4 minus 2, which is 2, which equals 360. And I think we covered that in a second ago. A heptagon. Now, how many sides are in that? See if you remember. Take a minute, think about it. Okay, there's 7. So we would do 7 minus 2, which is 5 times 180, which is 900. So a heptagon, which has 7 sides, has its sum of its measure of angles is 900, and so on and so forth. Octagon, 1080. Dodecagon, 1800. A 93gon, see there's where the example I was talking about, 93-sided polygon is possible. We could have an infinite number of sides. You might not be able to discern it with your eye, but we could have an infinite number of sides. A 93gon, we would do the same thing. 93 minus 2 times 180, which comes out to 16,380 degrees. Simple enough. All right, let's do a little bit more of a practical problem. So we're given the measure of angle A is 160. The measure of angle B is 50. The measure of angle C is 140. The measure of angle D is 150. We need to find the measure of angle E. So do you remember the formula? Okay, S sub I equals number of sides minus 2 times 180. Okay, that's going to give us the sum of all of these angles, and since we have 4 out of the 5, that's going to be useful here. So this has 1, 2, 3, 4, 5 sides, so we can do 5 minus 2 times 180, which is 3 times 180, which equals 540 degrees. So now if we add this up, all four of the sides, 160 plus 150, which is 310, plus 140, which is 450, plus 50, which is 500. So far we've got 500 degrees out of the 540. We'll subtract that, and that'll tell us that the measure of angle E is 40. Okay? So, simple basic math. This really isn't that difficult as long as you remember these formulas. If you don't remember them, you might be a little bit hard pressed, and some of this stuff might be a little bit difficult for you. Okay? Next, we're going to have to use our other formula. Now, we're not going to use the diagonal one for this, but we will use it another time. So, measure of angle F equals 110. Measure of angle G equals 80. Measure of angle H equals 74. Okay, but keep in mind, you got to pay attention to what they're asking for. They're asking for the measure of angle 1, which is an exterior angle, not an interior one. So what we need to do first is find the measure of HEF. And to do that, we have to first determine what that angle is, and we're going to use our formula again. There's four sides. This is a quadrilateral, -2. Now, yes, you might remember. Okay, times 180. 4 minus 2 is 2, times 180 equals 360. So now we add up these other angles. 110 plus 80 is 190. 190 plus 74 is 264. So we subtract 264 from 360, and that's going to give us 96. So if this is 96 degrees, what is this? Well, we know it's a supplementary, these are supplementary angles, so we can take 180 minus 96, and that's going to give you 84 degrees. So the measure of angle 1 is 84 degrees. So again, some simple usage to the formula, but if you don't know them, it's going to be hard to actually, do these problems when it comes time for a quiz or a test. So I suggest putting these in, note card, flashcard form, since you're going to need it for your project anyway, and since you can use those during your quizzes, it'll be helpful to have. All right, I believe that about wraps this one up. So again, I mentioned this last week. There's going to be a little 2 or 3 question quiz on Edmodo that you need to take after watching this. It should be easy if you've taken notes, and you can always go back and watch the video again to get the answers. I'm not putting a time limit on the quiz, just a due date. So that's going to be kind of my way, along with checking your notes, to make sure that you have actually watched these. All right, have a good day, and if you want, jump to the next video.